Some thousands of years ago, animals like horses and donkeys were the primary mode of transportation. Then around 4000 to 3000 BCE, someone invented the wheel and people started using carts. Then with the rise of trades and human hunger for exploration, people decided to explore the seas and the oceans. For that, they built boats, ships and discovered new pieces of lands. Then came the railways, automobiles and ships that are more advanced. In 20th century, Wright brothers invented the first ever aircraft. And in just 20 years after the invention of airplane, air travel became a very usual thing to do. Today in the 21st century, we have some advanced, fast and efficient modes of transportations available like the metros, the Hyperloop and the electric vehicles. So what is next? What would be the next milestone in our ever evolving transportation industry? Hi guys, this is Pratik and you are watching Eclectic. Here we talk about our past, present and the future. So if you feel interested, consider subscribing. Anywhere in the world in less than 1 hour. How does that sound to you? Quite exciting, right? Elon Musk and his company SpaceX may have already revolutionized the way we utilize rocketry. But now they seek to use their technology to take us to Mars, the moon and even from city to city here on Earth. And quite amazingly, the price of enjoying the city to city transportation could cost the same as an economy airline ticket. Known as the Big Falcon rocket or simply as the BFR, SpaceX's upcoming spacecraft is all set to satisfy all of our spacefaring needs in one neat package. BFR will be built upon the staggering success of their previous two rocket designs. The Falcon 9, which has successfully completed 9 launches in 2018, and the Falcon Heavy, which first took to the skies in February 2018. These rockets have demonstrated for the first time in our history that not only you can land the first stage of rocket booster on the ground safely, but also you can reuse it. Making rockets reusable is the key milestone for SpaceX and of course for the whole rocket industry. It is because of achieving this milestone of reusing rockets, the BFR's goal to not only take people off the world but also shuttle them around it becomes both viable and immensely promising for the future. So why reusing rocket is important? If you look at the cost of a Falcon 9 rocket, which is a quite big rocket, it is the lowest cost rocket in the world, but still it costs about $50 to $60 million. However, the cost of the fuel and oxygen and some other things is only about $200,000. So obviously, if we can reuse the rocket say 1,000 times, then that would make the capital cost of the rocket for launch only about $50,000. And of course, there will be some maintenance cost and all, but what is certain that we will be able to reduce the cost per launch significantly. This is pretty obvious and applicable to any modes of transportation. You can imagine that if planes were not reusable, very few people would fly because the most widely used airplane, Boeing 747, is priced at around $300 million. If they were not reusable, you would need 2 of them for a round trip. Okay, enough of this basic economics thing. Let us focus on the Big Falcon rocket. Standing at a mammoth 106 meters in total, the BFR will be composed of 2 major stages. A 50-meter tall booster which will be used to lift the vehicle into orbit, and a ship mounted at the top of the booster. This front portion will be equipped with 1100 tons of additional fuel and has a large pressurized cabin for people to sit and enjoy the city-to-city launches. This will give the BFR everything it will need to send customers into suborbit and speeding around the globe. Here, passengers will not only be able to arrive at their destination ludicrously quickly, but also they will be able to enjoy the majestic views of our planet that so far only a few lucky individuals have seen. Surely, those sights alone will justify the cost of the ticket, with the fast arrival time becoming a rather big cherry on the top. It should be noted that SpaceX is not alone in its lofty ambitions. Not so far away, another private company, Virgin Galactic, is creeping ever closer to their suborbital flights. They plan for these to initially be sold for recreation and research, but also harbor long-term goals of transcontinental transport. Unlike the BFR, their two-component system involves a jet-powered carrier aircraft and an attached rocket-powered ship, which releases from the carrier craft and launches towards space once at altitude. Currently, Virgin Galactic can take you to the edge of space for 4 minutes. 700 customers have already paid for this 4-minute experience. Across the Atlantic, UK company Reaction Engines also dreams of a vehicle that can soar from the runway to space as one whole unit. They have designed an air-breathing SABRE engine, which aims to be an alternative to pure rocket power or jet engine rocket hybrids like that of Virgin Galactic.
SABRE represents an entirely new class of propulsion, delivering the fuel efficiency of a jet engine with the power and speed of a rocket. A SABRE engine can accelerate a vehicle in air-breathing mode all the way to Mach 5 and transition to rocket mode to power the vehicle into space. Imagine traveling from New York to London in just over 1 hour. SABRE engines will enable a whole new generation of high-speed aircraft and spacecraft.
Although this technology is not currently as tangible as SpaceX's, it would almost certainly have incredible transport applications if it becomes reality. Now the question is, why SpaceX has been leading the race? SpaceX is pursuing the same decades-old goal with a new and a different approach. SpaceX's plan to utilize a suborbital vehicle for incredibly fast transport is not a new one. Even decades earlier in 1986, when Ronald Reagan announced his plans to fund a vehicle that could get from Washington DC to Tokyo in 2 hours, was not a some fiction novel idea. The difference between SpaceX's idea and those of the past has rested in their approach to the problem.
This may become the mission control room of the not-so-distant future, for a spaceship so highly advanced, fast and versatile that it would render the space shuttles as obsolete as the Apollo rockets. Able to fly direct from airport runways into Earth orbit and withstand temperatures of up to 5,000 degrees, the National Aerospace plane represents the future in aeronautics and space technology.
Reagan's government and NASA wanted to construct the National Aerospace Plane (NASP) as a single unit that could act as both aircraft and spacecraft with a unique engine design. They had shied away from rockets due to their one-use only restriction. But the answer to finding a commercial spacefaring vehicle, as SpaceX has shown, did not lie in finding a new way to generate enough thrust to get into orbit, but in a way to make the rocket stages reusable. Here is how city-to-city transportation on the BFR will work in 5 stages. Liftoff. 52,700 kN of thrust provided by the booster rocket will be used to lift the SpaceX out of the atmosphere. Cool ascent. Thanks to the engine's liquid oxygen and liquid methane fuel, the launch will feel relatively smooth and comfortable. Smooth journey. Above our planet's dense atmosphere, passengers will be free from turbulence. They can relax and enjoy the awe-inspiring views of Earth from above. Detachment. Its job is done. The booster rocket will detach. The ship's Raptor engines will then ignite, boosting the aircraft to a speed of 27,000 km per hour. Reusable. The first stage of booster will be able to land autonomously. It will then be reserved, refueled and reused. In 1873, Jules Verne published a story about a man's attempt to race around the world in 80 days. It is a tale of great adventure, but one that pales in comparison to the journey that we have taken as a species in the years since its publication. We have ascended from the ground to the air, and from the air to the realm beyond. In fact, such is the staggering progress of our technological prowess over these years that by 2025, getting around the world in 80 minutes may not be quite quick enough. At the end, here is the journey time comparison between flight time and the BFR time. on my channel I make videos on our past, present and the future, which involves dealing with the history, philosophy, politics and the future tech. Go ahead, check out the playlist and videos that are already available. Subscribe if you find them interesting, and also I assure you that more interesting content will keep coming up. If it is possible for you, economically support my channel on patreon.com.